Ever wondered how Node.js functions and how it manages to handle thousands of requests concurrently? Let's embark on this journey to uncover the world of Node.js. A powerful JavaScript runtime, Node.js is built on Chrome's V8 JavaScript engine. It's an open-source platform that's taken the developer world by storm, thanks to its non-blocking I/O model and event-driven architecture. This means it's designed to build scalable network applications and can handle a large number of simultaneous connections. This makes it a favorite among developers, especially those working on real-time applications. It's not just about efficiency though. Node.js also offers increased developer productivity, and its robust ecosystem supports a wide array of tools and modules, making it a versatile choice for various project requirements. So, how does Node.js achieve all this? How does it handle this multitude of requests without breaking a sweat? Let's dive deep into the lifecycle of Node.js and unveil the magic behind its performance. The Node.js lifecycle, quite fascinating, isn't it? Let's dive in and explore this intriguing process. It all begins with the initialization of the application. Here, Node.js loads the input script, which could be from a file or a module, and executes it. Now let's move on to the heart of the Node.js lifecycle, the event loop. Picture it as a continuous cycle that checks for tasks, executes them, and then sleeps until it's awakened by new tasks. What makes Node.js unique is its non-blocking I/O model. This is where callbacks and promises come into play. Callbacks are functions passed as arguments and are called when an asynchronous operation completes. Promises, on the other hand, represent the eventual completion or failure of an asynchronous operation, making asynchronous code easier to manage. Now let's discuss the different phases of the event loop. First, we have the timers phase, where scheduled callbacks are executed. Next, we have the pending callbacks phase, where I/O related callbacks are executed. Then we move to the idle and prepare phases, which are used internally and can be considered as the housekeeping phases of the event loop. Following that, we have the poll phase. Here, Node.js retrieves new I/O events and executes their callback functions. Should there be no callbacks, Node.js will check for set immediate callbacks in the next phase, known as the check phase. Finally, we have the close callbacks phase, where close events are executed. It's important to note that these phases are not standalone stages, but rather a part of a continuous loop that allows Node.js to handle multiple requests concurrently. So, in a nutshell, Node.js starts with initializing the application, enters the event loop, goes through various phases handling callbacks and promises, and efficiently manages multiple requests, all in one go. So, that's how Node.js manages to work its magic, through a well-orchestrated lifecycle. Quite a journey we've had through the lifecycle of Node.js, right? We've managed to dissect the complex mechanics of Node.js, breaking it down into digestible chunks. We dipped our toes into the initiation phase, where our application springs to life, and moved on to the event loop, the heart of Node.js that keeps our applications ticking. We touched upon the worker threads that handle the heavy lifting and keep our main thread unblocked, ensuring smooth, efficient operations. And finally, we explored the exit phase, where our application tidies up and says its goodbyes. This understanding of the Node.js lifecycle is crucial. It's the difference between writing code and writing efficient, scalable code. It's the difference between being a good developer and a great one. And there you have it, the Node.js lifecycle demystified. Remember, understanding the core of a technology can truly elevate your skills as a developer. Until next time, keep coding.